Welcome back to Robotics 101, training for ag teachers and ag tech coaches. In the chat, okay, let's try this again. Copy link address. And now in the chat is a link to the presentation, so you can get to the other links embedded in there. And the first thing I wanted to talk about is, it was a question that came up after the end of the workshop, which was, okay, how do we put these things all together for an application that does something more than demonstrate one particular sensor? And so we talked about the approach to that. And so before kicking off with that, I wanted to show everyone what students can do. This robot has faster motors than we've got, and so you'll see it seeming to move right along. So that is an example of certainly higher speed relative to size than we need for most agricultural applications, but it's certainly easy enough to slow it down. So let's focus on putting together what's needed. So the whiskers are not needed for this particular app, although we could put something in the way, have it bump into the whiskers, circumnavigate the obstacle, and then continue. But for now, let's just put the two together. Basically, the stop when you've reached the garage and the following the stripe. So with that, what I'd like to do is share a link to a folder with all the scripts for today. Although it's labeled Python Cyberbot Husky Lens, which is the vision sensor, we are going to also, I've got our pavement following and our photo transistor voltage stop in shade scripts in here. So here is a link to the folder, and you can either download each of these individually, or you can download the whole thing as a zip and unzip it. And also, I would like to point out that the link to this folder is also right here in the slides. So you can copy, you can follow the link from there and end up in the folder as well. Okay, so can you folks give me some thumbs up that you have the folder downloaded? Okay, I got one thumbs up. I am going to, I think, paste the two links for the new arrivals. Yeah. See, I just saw a few people arrive. I don't know if everybody saw the links or if they appear if you don't, if you don't, if you joined later, I think the links might not show up for you in the chat, so I'm repasting. The very most recent link is the slides, and we are on slide 85. And then the second most recent link is the is the folder with scripts that we will be using today.
Hey Andy, can you define that folder for me again? I'm seeing Python, Cyberbot, Husky Lens. Back me up
Do
to
you
the
see
folder.
anything inside it?
I see everything inside of it. You want me to download each of those to a different folder?
Yeah, or you can, if you click up here, see do you see like any breadcrumbs upstairs, or do you see it say,
Yes.
okay,
Yeah.
you should be able to click it and you can download and then unzip it if you want, or you can basically click the three dots by each file and download them individually.
Okay. Got it. Thank you.
You're welcome. All right. Um, so we're going to start with, I'm going to download this, the phototransistor voltage stop and shade and pavement following. And I'm going to open those in two separate editor instances. So going to downloads here. Interesting, I didn't get all of them. Let's try pavement following again. Oh, I didn't allow the download of multiple files from the same place. Okay. So I'm going to open, like I said, I'll make two two editor instances, and then we'll open pavement following in one, and we'll open phototransistor voltage stop and shade in the other. And so again, this is to answer the question of, okay, well, I've got one script that stops in the shade and then a second script that follows the road. But what if we want it to follow the road until it gets to, a shady enclosure before stopping? How do we integrate this into that? And one of the things that's going to be really common is for students to do something like take the whole thing and then just paste it down below the rest of it. And there's a problem with that because we have this while true loop here that's working on turning towards the road, but so that's going to repeat these statements over and over again because they're below and indented from the while true. So then the other script, all of its statements, if we point at this little note here, it says code is unreachable. The logic in your program means that your code will never run. So this is a very common thing for students to do. And I'm going to Control Z to undo that and get us back to where we started. So guiding students through analysis of the script so that they can understand what pieces they need turns out to be probably the most beneficial way of getting everybody started on this. And so actually talking through it and saying, okay, well, all this stuff up here is imports. They're bringing in these modules. These modules are in our project here. They all have various code that can do jobs for us. And all we have to do is use the name of the element in the module. And so we've seen a fair number of examples of that. And then we have, this is called a function. And so this is the piece of code that is reusable. So for example, here we see it calling QTI detect. And when it does that, the script jumps up here, does all this, and then sends back the values of QTI left and QTI right, which we capture right here. And now inside this while true loop, again, this is repeating over and over again. The first thing it does is it reads the QTIs to check if it's on or off the road. And then these statements are all making decisions based on, well, did both the QTIs see the surface of the road? Great, let's move forward for an instant and then come back around and check again. And we keep on checking, and maybe that's still the case. But then if maybe the right wheel or the right sensor falls off the road, then it'll do this maneuver to reverse the left wheel to bring it back, to turn left to get back on the road. And with if and elif, when it's a chained set of ifs, if, else if conditionals like this, it only does one at a time, and then it jumps out and comes back around and rechecks and redecides. So that's how this script is working. Now, if we go and look at this script, okay, well, we're bringing in the Cyberbot module. That's great. And this is another endless loop. Well, that is until our voltage on the phototransistor goes below a value, and then it jumps out here. But looking more closely, what's happening here is that pin 2.read analog, that's the pin that's AD2, or pardon me, pin 2.read analog. Pin 2 is what's connected to the phototransistor. And so the value, which could be 0 to 1023, gets stored in a variable named AD2. And then this is the line that converts that to volts. We take AD2, we multiply it by 3.3, which is the voltage supply, and then we divide by the number of levels that the read analog could have measured. And that's how we get the volts. And then this displays the volts in the serial monitor. This sleeps for 100 milliseconds, and you'll want to tell students to be careful with this one, because if they leave this one in the code, it could make this road following much more sluggish to respond. Then we've got an if statement here. It says, well, if the volts are below this 1 volt threshold that we figured out by testing is what meant it was in shade, then stop the servos and then break out of this infinite loop, of this endlessly repeating loop. Otherwise, just keep going forward. Now, if we do break out, it's going to display an X on the display. So when students walk through this, then we can talk about, okay, well, what do we really need from this? And I would say that what we need is to check the voltage and convert it to volts. And then we maybe need to say, well, if that voltage is below the threshold, then break out of the endless loop. And that actually, to me, might be it, because this other stuff where it's just ambling forward slowly here needs to be replaced with all this road following stuff. So the idea would be that we'll take, and what I'm going to do is take this whole chunk. Okay, so we're going to read the voltage, print it, and then say, well, if it's below that magic number, let's just stop everything. Let's get out of this endless loop and move on to whatever's below it, which is this one thing right here. So we can take all this and paste it in right here. Okay, and so now we have the check for shade routine, and we have the follow road routine. And so this endless loop, and remember that I said that it's probably not a good idea to wait for 1/10 of a second. We want it to be more responsive to the road rather than getting lost. And even printing the volts, maybe we don't want that. I mean, it's good for testing, but we can take it out of the script for now, if, assuming that we've tested both of these scripts and they work really well. And then, of course, remember to do a save as, and, maybe something like follow pavement to barn, confirm, and then save your first iteration of it. Okay, so let's see if that works. Okay, so need to connect my USB cable to the microbit here. Okay, so here's our robot with its light sensor. And QTIs, and so all that was set up and tested from the previous time. Okay, so the power switch is currently set to 1, meaning that it's not going to move, but we can see that we've got a good response here to the going off the road, so we know the QTIs can see the road. And we'll hope that the light conditions are still equivalent. And so what we'll do is we'll have it follow the road until it reaches some shade. So I'll go ahead and hit send to microbit now. And so again, I have this set really slow because it makes it easier to demonstrate. So it's following the road. And then we'll have the shade. There we go. And it stops. Now, for some reason, oh, you know what? So one thing I forgot to do was put the little thing that said that we're ending. So that was display dot show image dot capital I image dot no. All right, so we'll just rerun that and I'll paste that script in if it looks like it's going to work well. So it's following the turn and then boom. Okay, so we've got that nice X saying we're all done. So there's an example of integrating 2 working applications, and that is actually most robotics manufacturers try to publish a whole lot of applications, and then makers of parts that are going to go into the robot will publish, oh, well, here's an example of using our part. So this activity we just went through is kind of a core one for students to get used to. And we do a lot of this throughout the robotics tutorials at learn.parallax.com, but I thought that this would provide a good example. And thanks again to whoever asked about that after class last time, because I like this as an exercise for integrating 2 scripts. And I'll go ahead and copy all this and paste it into the chat. A similar piece of code is also right here, follow road, park, and barn is one of the scripts in our folder for today. Okay, so are there any questions about that? I kind of saw a look that said, oh, where do I even begin? And then a nod. Well, let's get started. Or would you like to just kind of check and see if this works on your set up and play with it a little bit first.
Andy, so just a second ago, you mentioned that, this is a good example of, integrating different technology to different companies.
Yeah.
If we relate this back to like the Amiga system, they're going to have the preset code or some sort of preset code to where we can kind of weave together if needed. Is that
Yes,
what you mean by that?
absolutely. They let's see here. I need to see if I can find the web address of their um, I'm looking at my phone because I left it open in my phone's Google, I think. Um,
Sorry, I keep asking the Amiga questions, but we're trying to
oh no,
get
it's completely
without
understandable.
without actually having the unit yet or any, haven't heard much back from Arav as far as that stuff. So just trying to, I guess, put things together without looking at the actual stuff.
Yep, that's understandable. So this right here is a good thing for students to get started with that kind of integration because that way they're comfortable with it when it comes along to the bigger robots. Let's see, Amiga dot farm ng dot com slash docs slash concepts slash system underscore overview. Let's see if this gives us, okay, I misspelled it apparently. Okay, Amiga dot farm ng dot com slash docs slash concepts. Maybe system needs to be spelled without two S's. Still no good. Um, okay, well, there we go. Um, all right, so here's the quick start. And this goes through all the stuff that I saw, it looks like, when Arav delivered his robot. Let's see, paste. And then if you look at the menu on the side here, uh, we could, we can look into mechanics, electronics. So here it talks about the intelligence kit. Um, and so these usually have single cables. It's called a CAN, CAN for controller area network bus. And let's see here. I saw earlier in this list something that I wanted to show you. Back to main menu, maybe. Here's developers. Okay, so under developers is typically where I would expect to find the API Amiga Development 101 guide. Here we are. Okay, so this is going to talk in detail about, look at this, open source code examples. So this would be a place where, and this, yeah, that's interesting because that looks a lot more, oh, hold on.
That's not much in the way of examples there.
No, it isn't. back to Amiga Docs. Okay, so here is an example with, oh, interesting, look at this. They've got this little peripheral microcontroller kit and a CAN bus cable. Yeah,
Andy, I don't want to, sideline everybody else with my Amiga questions, but
okay, well, did I paste that other, because this, now here we have some, that this is, this at least is a GitHub repository where you can take a look at some of their code. So I think that spelunking around here is going to help. So I'll give you these two links and then we'll go ahead and jump back. Paste.
perfect. Thank you, Andy.
You're welcome. Got one more for you. Copy link and paste. Okay. So yes, this is kind of the beginner level integrating two different sensor subsystems together and making them play nice in navigation. So if we think about it, what it's doing is it's doing all of this stuff every time through the loop. It's going to, keep on going through and deciding what it needs to do and then come back and repeat it again. So every time it'll take a measurement, convert it to volts, check if it's less than a volt. If it is, then it stops the servos and breaks out of the loop. But if it's not, it goes on and it checks the road sensors. And then it makes its decision for, which way to go on the road. It does not make it to here. It just goes back up and repeats this over and over again. And so here is our little routine for checking for shade, and then here's our little routine for following the road. And the idea is that we can check for shade first and then say, well, if there is shade, break out of this whole loop, but if not, go ahead and let it go to the road following. And so so that's, like I said, it's a nice little piece of code. And it demonstrates a pretty powerful concept. Okay, so the next thing I'd like to do is somewhat unscheduled. Let's talk about the standard servo, because there's one in your kit. So here we can see this little box right here, this little black box on the front of the robot, that is a standard servo, and we have one of those in the kit with the Husky lens. And here it's turning this turret back and forth and doing using ultrasound in a radar sweeping back and forth kind of way. And so your standard servo should be right in the same bag with the Husky lens camera. And so what I'd like everybody to do is just grab that. And then we will be using this soon. But let's go ahead and just take this. And I think I'll just put something on it to make it meaningful here. Using advanced twist tie technology. This is a place where those of you who have your students doing 3D printing will potentially be able to add some fun, because students can exercise some creativity and inventiveness while creating a various extensions. So this can be mounted on the robot, and it could become a weed disturber or a tree chopping down device or what have you. So if we're using, for example, paper, trees that are stood up on little paper stands, for example, that would be helpful. Now, careful, because when you put on the servo, don't do what I just did. And notice how the black wire here is closer to the edge of the board. But over here, all the white wires are closer to the edge of the board. I have this plugged in upside down. And so although it won't damage the servo, it's also somewhat disappointing when it doesn't work. So we're plugging this into the P16 socket. I'll zoom in on this a little bit. And you guys don't need to, add an end effector, i.e. a writing instrument in this case, to it. See if I can get this into focus. Looks like it was. Okay, so this servo, the standard servo, is connected to the P16 pins sticking up. So you'll see one empty set of pins to the right of it. And then there's the P16. Okay, give me a thumbs up when you've got your circuit made. One, two, three, 4, 5. Okay. So now let's I'll just go ahead and add a little test routine to this. So it's going to be bot of 16 dot servo, and notice that we have the option of servo angle. So that's the one we'll need. And I don't remember actually whether it's degrees or tenths of a degree. So we'll try it at degrees and see how this goes. Send to microbit. Oh, cancel. So let's just try sleeping. Sleep 1000. And we'll actually try, I'll paste this in a second, so just watch for now. Okay, so we'll make the rest of the stuff down there unreachable and just do a little test here at 45 and 135 degrees and see if that gives me any motion or just barely like, oh, while true. Okay, so send that to microbit. See how it's going between, it's going about 90 degrees apart and it's self-destructed. Oh no. But if you firmly attach something to the, this is called a servo horn. What this standard servo does is you'll see standard. So I'll set the robot switch to 1 so it stops moving. You will see that this is a standard servo as opposed to the continuous rotation servos that we were using earlier. And so you can actually tell it what angle you want. So I'll even do kind of a fun program here. Let's see, print, enter. Well, I'll paste this to you first so you can give it a try. And while you're trying that, I'll type in another code example. Paste. Hey, why didn't that go in? Send. Okay, there. Oh, you know what? I didn't give you everything. Sorry about that. Bear with me. Okay, this time it should be the complete script. Now you'll need to open up a working Cyberbot program because it needs the module inside the project here, that Cyberbot module. Okay, and then let's see here. Print, enter angle. Let's see here. Text equals input of, oh, enter angle. It's a better way to do it. Then angle equals int of text. So we're essentially receiving text from the keyboard and then converting it into an integer value here and then storing it into angle. And then we can say if angle is greater than 0 and angle is less than 180, colon. Then we'll use angle, the value stored in angle, to make our servo go. Okay, so let's see if that works. Okay, now keep in mind you're going to have to use show serial to see the text. And so I will type in the text and I'll say 0, ooh, greater than or equal to 0, and less than or equal to 180. Let's try that. And we need to make sure to turn the power switch to 2 over here. Okay, so send to microbit and enter angle. We'll start with 0, 45, 90, 135, and 180. And back to 0 and back to 45 because it looks like 0 is actually causing it to push up against its own mechanical stoppers. I can hear just a little whining that it's trying awfully hard. Okay, so I'll go ahead and paste this one over for you to try as well. Paste. So Carson, did you see the circuit that that I connected for the servo, the standard servo? Where I wasn't sure if you were able to see it earlier. It was basically I took the this servo out of the Husky Lens kit. It's a standard servo, and so it holds a position as opposed to turning continuously like the ones behind the wheels on the robot. And I connected that to the the socket labeled P16.
Yeah, that's what I have connected there. I'm just a little behind from I missed Mondays, so forgive me on
Oh,
that.
I see. Okay. Okay. Well, you'll be fine because we're going to be moving on from the road following. Although you will want to get the road following going for next Monday, because we're going to follow the road, but stop by each plant on the roadside, and so we won't necessarily be paying attention to the light sensor anymore, but we will be following the road and watching the roadside. Okay, so has everybody gotten their standard servo to point in different directions in the 0 to 180 degree range?
I have not. I don't know what I did wrong here. I've cut and pastes into the same.
I'm with you. I'm in the same
Um,
spot.
Okay, so did you start by opening one of the projects? Like if you click project, do you see main.py and Cyberbot?
Yes.
Okay. If anybody does not, then tell me no.
But
Okay.
when I open that screen down below, mine
Mhm.
just says microbit flashed, and it'll have an N there. It doesn't come up with the what you have is the different angles.
Okay,
Yeah,
so
I'm
now
not getting any
there were
data.
two scripts that I put in. There were two scripts that I put in. So the first script, let me go back to it. Well,
Or overwriting the other one, right?
yeah,
Okay.
yeah. Um,
I did the first one where it went just to 45 and stopped and it worked.
okay,
Am I?
so
Yeah, and it grayed out when I put it in that new one.
yeah, and that is to be expected. So the idea would be whichever one you want to have running, you would put immediately below from Cyberbot import star. So like right now this one's running, but if I instead wanted to run the sweep back and forth, notice that if I put it in right below from Cyberbot import star, this is the thing that repeats indefinitely, and then everything below gets ignored. But I can instead take this and do it instead. And so this one right here will not show us anything in the terminal. When we're just going back, when we're just sweeping back and forth, there's no terminal interaction needed for that one. But then if you put this one up top instead, now this one should have the terminal interaction. So if you hit send to microbit, and I was disconnecting and reconnecting my microbit accidentally here, so I don't know if I can. Here we go. Okay, so if I send a microbit now, nope, it's not going to work. Okay, so I'm going to, I guess, save this as standard servo tests. Okay, so we'll save that. And then I'll go ahead and close that window and then try going back to python.microbit.org, reopening the script. And resending to microbit. Hmm. Okay. Unplug the microbit from the robot, unplug the cable, turn the robot off, plug the microbit back in, and reconnect the cable. Okay, let's see if that does anything for me. There we go. Okay, it's not showing me any messages. Sometimes if I hit these three dots up here and hit Control C for REPL, and then three dots and Control D to reset, and then send the microbit one last time. Well, that's interesting.
Yeah, so I did the same thing you're doing, and now it works.
Oh, good.
Something comes up where I can change the angles.
Okay, and then
I just
can you type
reloaded
in
it.
and
I
hit
loaded
enter?
something else and reloaded it, and it worked.
Okay, yeah, for me, yeah, I'm not getting mine to work quite yet.
I'm still not getting it to work either. So
Okay. Gonna put a 2,000 pause in there just in case for whatever reason it's missing. Yeah. I can hear my CPU fan whining too, so I'm not sure what's going on here. Not too much open here. I'll close a few browser things. And close this one. Okay, then bring up a new browser. Oh, okay, this might explain what was going on. I had maybe another one connected to the serial port. So if I had probably too many browsers open, and one might have been connected to the USB. And then I tried to load code from a different one, and sometimes that can cause the one that's talking with the microbit over USB does not let go of that connection. So that's a good thing for your students, is to try to get them to keep only one window where they do the programming. They can have multiple windows open, but it's best to only have one open for loading code. All right. Well, that's interesting. It didn't even get my sleep 2000. Okay, send to microbit. There it is. Show serial.
Does this servo only go 180?
It only goes 180. It goes a little over 180. But yeah, 180 is the range of the motion. And so this is this servo right here is one that you tell it to turn to and hold an angle. So it's the kind of device that you'll find controlling remote controlled airplane flaps and remote controlled boat rudders, super small boat rudders at any rate. And so because, and it's also done in little mechatronic things, like, for example, props for haunted houses, and student sometimes animatronics uses these to have things move automatically. Yeah, I really wish my serial monitor would come back. But it looks like it's not going to do it, so that's okay. Did you folks mostly get this to work now?
I never got this version to work.
Okay. Okay, tell you what, let's do another version. Let's at least end with something that's kind of fun. And I'll take a look at the serial monitor. Sometimes, like if Chrome goes through an update, the editor falls out of sync with it for a period of time until they get an issue fixed. So we might be looking at something like that. We might be looking at a mistake that I'll have an aha moment about after the presentation is over. I don't know which one it is. Regardless, there are some buttons built onto the microbit, and so this one's kind of fun. We can just use the buttons on the microbit. So if button underscore A dot was underscore pressed colon bot 16 dot servo underscore angle of 45 elif button underscore B dot was pressed colon, and then we'll do the 135 again. And if neither of those are the case, we'll just repeat the loop, else pass. Okay, and then we want to get rid of all the rest of this. Okay, so let's try this and see how it goes. Okay, so if I hit A, send a microbit. If I hit the A button, oh, you know what? Okay, for me, the problem with that previous code may have been that I had the switch to the robot turned off. So maybe, I don't know if any of you had that, but that is a definitely possible explanation for this. So I'll run this and then hit the A button. We want to have it in 2 to control the servo. So the PWR switch down here has to be set to 2. And then if I hit the A switch, nothing still happens. Okay, there's the B switch, and it went over to 135. And now the A switch takes it back to 45, 135, 45. I'll paste this one in for you. Copy, paste. And then I will also try this one again. Yeah, so this is back online. Okay, so this does work. I can vouch for it now. I hope that for those of you who were watching who couldn't get it to work, maybe turning power on will make a difference for you too. And you'll want to have it set to the 2 position on the Cyberbot again. That's right here. The reason I was not seeing anything is basically because, like, here the program starts and it sleeps for 2 seconds and then it shows me enter angle. But if I had the power completely off and hit send to microbit, what's happening right now is the power is off to the Cyberbot board. So the microbit is sitting there and it's waiting and it's waiting and it's waiting to hear back from the microcontroller that's underneath this white breadboard. It's on the other side facing the robot chassis. And since that chip isn't awake to talk to the microbit, it just keeps waiting. So if I turn the power on, maybe after 2 seconds, we will see, there we go, enter angle.
So mine was on,
Okay.
but I got a weird reading on the serial. It just said it would say a single letter, like the letter R or the letter L, and then I got the letter E, and it said E space angle lowercase the first time, and now I'm seeing it the same as yours, but I didn't get that for a long while, and it was on.
Part of this is just that with the amount of resources that both Zoom and Chrome take, some computers can find it overwhelming. And so I don't know if if you have a super great gaming computer, then that's not the case. But
no, the school district has my new computer and they're reflashing it. It's in my back office. I haven't gotten it done yet. So more than likely it might be on the right track. It could also be that the USB is running through an adapter to get in my computer right now too. So
yeah, that will also have an effect. Sometimes adapters don't even supply enough power to keep the microbit going. So it's hard to know. Some adapters are great, and then others are can actually throw a number of ghosts into the machine.
okay, well, it's fixed now, so we're good. Thank you.
Excellent. And it is now 4:45, so let's go ahead and take a break until it's actually 4:48, so let's take a break until 4:52. Okay, welcome back from the break, everyone. What we're going to do next is connect our vision sensor to the robot. And again, this was a slide from earlier when I mentioned that, hey, we've got the Amiga robot. This thing has a supercomputer in it and really powerful processing for whatever it sees with the camera, because we need to be able to recognize that we're on a row, which fruit to pick, and all those other things. And so for the Cyberbot robot, what we have, this is called the Husky lens camera. It's a AI model trained camera where the model was created and trained to be able to recognize certain items, and also to be able to recognize how to recognize certain items so that we can train it with great ease as well. And so this is what the kit looks like. And so what we're going to be doing next is finding the rest of the parts that were in the Husky lens camera kit. So that's what we'll be using now. And we'll want to make some room for ourselves here. So what we'll want to start by doing is let's go ahead and remove the standard servo. And then we'll also want to remove all the whisker stuff. So that's going to be these 2 resistors, these 3 pin headers, the actual whiskers, which are attached here and here, And there's one wire here, or no, this is actually, we'll keep this. Actually, I'm not sure if we're going to be using this anymore, but it's kind of out of the way. So we'll go ahead and keep the light sensor stuff. So it's just these two resistors. Then there's going to be another pair of resistors underneath the cables going to the QTI sensors in the front. All right, so let's go ahead and see, where's the parallax screwdriver? Here it is. So we'll go ahead and loosen these screws and remove the whisker wires. And then retighten them. Remember to turn power off. Okay. And next up, the 220 ohm resistors, the red, brown resistors that are connected to P7 and P9 can come out. So these two right here. All right. And these two 3-pin headers can come out. And the two resistors that are going from 3.3 volts to the 3-pin headers can also come out. Okay, so that should clean up our board enough to add the connection to the Husky lens. Now be careful and don't sneeze, because we have a micro SD memory storage card. Make sure that you set that somewhere where it cannot be misplaced, because we'll be adding that in a little bit later. But in that same bag is going to be a 4-pin header. So this right here has 4 pins instead of 3. We've been using the 3-pin headers to attach the QTIs and build the whisker circuits. But for this one, you could just line up 2 3-pin headers in a row and use 4 of those 6 pins. But this nice 4-pin header is going to be exactly what is needed. So make sure to have the 4-pin header. Make sure you know where the micro SD card is. And in fact, we'll probably, just as we put this together, add in the micro SD card. It might be easier to do before we mount it. Okay, so what I'd like to show you next is how to get started with this. This, by the way, is the product page. And so, like, if you click this, it'll have a link. It's kind of difficult to see. Okay, there it is. Copy, paste. So that's the Husky Lens Kit product page. And then this is the Python page for it. And I'm going to copy this and paste it into the chat as well. And actually, we'll also navigate over there. So on the prerequisites, these are things that we did pieces of, like navigation with the Cyberbot, building the Cyberbot, adding modules we kind of looked at, writing microbit programs. We talked about how to learn Python there. And getting started was what you did even before coming to the workshop. So these are the same prerequisites that were done for the Cyberbot. And then here we are in the Husky Lens. And so your first thing is going to be to gather your parts. And so I'll have you all open that up in a screen and gather those parts. These parts are all in the box here. I'll have this back up in a second. Okay, so these parts and yeah, so these parts, let's go ahead and grab them and hold off on a second before you connect this all like this. Those parts are in this box. So I am opening the Husky Lens box. So there's the Husky Lens camera. It's in this little black anti-static sleeve. And then down below here, we will find the cable that we'll be connecting to the computer and a bag with a bunch of small parts in it, of which we can use the empty box for some handy small part storage. Now, before you mount the Husky Lens on the front of the robot, I would like to try something because I'd prefer to have this mounted on the side. So can we fit it there? Oh, we can, but it's going to be kind of a pain to mount there. How about here? Yeah. What I would like to do is mount the Husky Lens on the back right side of the robot as opposed to the front as shown in the picture. So turn power off and we can unplug it briefly. And what we'll do is, you know what, I would say in the Cyberbot robot parts, we'll want to replace that 1/4 inch screw with a 3/8 inch screw. So I would look first of all in the Cyberbot parts to find a 3/8 inch screw, and then what we'll do is on the back right of the robot, we'll mount the bracket so that it is hanging off to the right. And this is all in preparation for the project where you will be um, it's part of the final project, so we want to be able to see plants on the side of the road. And so now we can go ahead and take the protective cellophane off of the screen. And there is this nice part here. And so now we're going to be using, for the rest of it, we'll be using the screws that come with the robot kit. And this bracket is going to go in between the two arms of the other bracket. And we want to make sure that the mounting holes for the Husky lens are pointing away from the robot. And then we'll use the screws that came with the Husky lens to attach this upper mounting bracket here. So essentially we're doing a mounting similar to the one on the front of the robot, but we're just mounting it looking sideways and on the back side of the robot.
Hey, Andy, from your orientation, it's hard to tell which direction the curves are and if that bracket's one way or
Yeah, I was worried about that. Thanks for mentioning it.
perfect. Thank you.
You're welcome. Okay, so I just about mounted the Husky lens, but it's going to be way easier to put the SD card in it right now. So I would say before you put the Husky lens on its mounting bracket looking sideways, you'll want to grab the SD card. And the SD card, while not required, it just saves so incredibly much time, because if you train the Husky lens to recognize certain things and then turn off the power completely, you can end up losing some of that. But if you have or all of it, but if you have this nice little 8 gig micro SD card in the socket, you can save your training data to the micro SD card. So, so that's why we wanted to have that in the kit. And so go ahead and put the SD card in right now, because it won't hurt to have it in there. And then you can go ahead and attach the Husky lens. Now be careful, you want the screen of the Husky lens facing toward the micro bit. So the camera lens is going to be pointing this way, and the screen will be pointing that way. So again, double check that the screen is on the microbit side and then the camera itself is facing away from the microbit. And there's also a little lens cover here on the lens itself. See that little red tab? We'll want to remove that little red tab and its plastic covering so that the lens is not obscured by it. I'm actually going to point mine down for demonstration purposes. And we can worry about loosening it and pointing it sideways later. Okay, so go ahead and give me a thumbs up when you've caught up to that. And, oh man, you guys are so fast. We've got 3 thumbs up. 4. Okay, so I'll just repaste this link in. So you can use that as a reference, or if you want to just take a screen grab of this, that'll work too. Well, if my computer stays on that screen. Okay, here we are back on that screen. Okay, so next up, we're going to connect to this. And so we're going to go to the next page here, where we're going to get the 4-pin header I talked about, then this you'll see in the kit, and a couple of resistors with the brown, black, orange color code. And you'll go ahead and set it up like this. It's on the next page from the link I pasted. Send. Okay, so that's, I just pasted in the link to this page where we have our parts and our wiring diagram. And so what we'll want to do is add this circuit. Make sure that you're connecting, be very careful with your resistors. If you can, zoom this in on your screen so that it's a little bit larger than life. So you could right click and open the image in a new tab. And I'm actually going to paste this image through to the chat as well. Okay, so this is what we'll want to build. Okay, so 1, 2, 3, 4, 5, 6. So we'll want to put the top pin of that 4-pin header on the 7th row from the top. One, two, 3, 4, 5, 6, 7. I'm going to double check that. One, 2, 3, 4, 5. Okay, so it looks like I've got that in the right place right now. So we'll go ahead and plug that in. Then we need our brown, black, orange resistors. We had a pair of those on the whiskers already. So brown, black, orange. And then, oh, all points bulletin. Everybody look up. We are going to take this red wire, and for improved performance, instead of putting it on 3 volts, we're going to have it on 5 volts. So this red wire, instead of going to 3 volts, let's put it on 5 volts. Okay, so that red wire goes to the top of the 4 pins. And then it goes around to a 5 volt connection, not dissimilar from the QTIs. Okay, so that was the top pin, same row as the top pin, going over to a black socket with the 5V label above it. Next up, we've got our 2 brown, black, orange 10K resistors. And we'll take one of them and connect it to that 5 volts. Actually, we'll do that for both of them. And then one will go from 5 volts down to the second row from the bottom of the 4-pin header, and the other will go to the bottom row of the 4-pin header. So let's see here. So I'm on the inner one right now, so that's going to go clear to the bottom row. And then we'll take a blue jumper wire to P4. So from that bottom row with the bottom pin, it goes to P4. Then the second 10K resistor, again, that's brown, black, orange, will go from 3 volts to 1 row up from the bottom pin of the 4-pin header. So that's this row right here. It's going to have a 10K going from the red wire that goes to 5 volts and then back up around, and so one end will plug in here, and then the other end will plug in the second row down from the top, or the third row down from the top. Immediately above the one that we just plugged in. So top row of the 4-pin header. and then one up from the bottom row. And then the one up from the bottom row resistor connection will go to P5. What I'll want you to do is, and then make sure that the resistor leads are not touching each other, because that will interfere with communication with the vision module. Oh, and then the second row from the top has a black wire coming down to one of the black GND sockets. That is the most common cause of ghost in the machine behaviors when you have systems like the microcontroller on the Cyberbot board that's trying to communicate with a system like the Husky Lens. If they don't have a common ground, all kinds of crazy things can happen. Like it can appear to work for a little while and then stop and then start working again, or not work at all. Okay, so go ahead and give me a thumbs up when you think you've got that wired up as needed. I hope that, okay, 1, 2. Oh, good. 3, 4. 5. Okay, way to go, everyone. Next up, we are going to connect our harness. And you'll want the red wire of the harness to go to the top red wire that's jumping over to 5 volts. And then, everything down from there. So I'm going to open this in a new tab and then paste you the link of it. Okay, so there's the link to that photo, so you can open it on your computer if needed. It's also another good shot. If you want to double check your circuit from this angle, just remember, instead of 3.3 volts, we're going to be over here in 5 volts for where this red wire is going. And then here's our brown, black, orange resistors. And then our jumper wires connecting the second from the bottom row to P5 and the third and the bottom row to P4. So double check your wiring there. And then last but not least, we've got the ground coming over from second from the top, going all the way to GND. And then we'll put the harness on. This is the harness. Maybe if I'd have had this third twist tie, my servo pen swinging machine would not have self-destructed. Okay, so we are going to take these separate ends right here, and those are the ones that we're going to plug onto the 4-pin header, and make sure to get the order so that it's red, black, blue, green from top to bottom. So we've got red, black, blue, and green, like so. Make sure they're all the way down on the pins. Give me a thumbs up when you got that step, and we'll move on to the next. 1, 2, 3. Good job. 4, 5. Excellent work. Okay. Then I think it's probably a good idea to snake the other end down under the robot and have it come out the back. So, so see how the cable is going under the robot and out the back. That way it's not going to get potentially pulled around by the wheels and have it try to unplug up here. Oh, okay. Well, I'm going to have to loosen this up because yeah, I won't be able to be pointing completely down. But here is the JST socket for the other end of the cable.
And is there any problem if the wires are twisted, like electrically?
If they're twisted like so, no.
So what I did
if-
is to keep it a little cleaner.
Yeah, that'll be
Maybe.
fine. Good question. And yes, it'll be fine. The insulation and air gap between the wires is sufficient to not have them interacting with each other.
So twisted this way, okay.
So now I should be able to see, is that the right direction? I believe so. What you want to have is the little grooves on the JST connector should be on the top. I think I'll try to get you a close-up of that from the web page. Basically, it won't plug in the other direction, so you put the grooves on the top, then it should plug in nicely. And then if you're going to have it pointing down like mine temporarily, no need to force it to horizontal. Just have it a little above horizontal and that'll be fine. Okay, and next up, we need to test our system. And so we'll want to reconnect power. Now, if you turn it on and the lights don't turn on, then turn it off immediately. But if you turn it on and you see a camera, that's a good sign. And it's hard to see maybe your face, but it will recognize faces by default. And so if you happen to have like if you take your phone and just bring up a picture of a face and put it in front of the camera, if I back it up a little bit, it might, there we go. Now it's got, let's name him Bill. And then this guy's face is immediately recognizable as well. It looks like Bill's a little bit nondescript. So if it recognizes faces, we'll know that the power is good. So go ahead and give me a thumbs up when you've turned on power, and if you see anything, you know, if you can see whatever is on the other side of the Husky lens, that's definitely step one. Thumbs up, thumbs up. So that's 2 that I saw. Sorry if I was looking away. 3, 4, 5. Okay. Give me a shout out if you need extra time. So what we're going to do next is we're going to try training the Husky lens for color. Or wait, let's see. I believe that I might have skipped something. Let me make sure here that test it. Okay, so our first test script will be learn one color. And for that, we'll need a brightly colored object. So I'll go ahead and copy this over. Now this script won't do you much good because it's a screen capture. And you'll need to normally download Husky Lens project, you know, microbit Husky Lens project.hex. That'll have all kinds of good modules in it to get this stuff done. And then you would type this in, but we have our nice Google Drive. And let me know if you need me to reshare this. Otherwise, if you downloaded everything at the beginning of the workshop session, just grab learn1color.hex and load it into your microbit Python editor. So learn1color.hex. Okay, hopefully that's the right one. All right, and send to microbit. Okay, so with learn1color.hex, we'll have to find a nice color for it to lock on to. So after you've loaded learn1color.hex and made sure power is on, you'll see that it's looking for a color to recognize. And the bounding box, which is all over the place without a defined color, goes ahead and focuses. When you put the color under the crosshairs, it focuses on it. And so then you can press the A button on the microbit right here. And then it will show you color ID 1. And I don't know if B will forget it. A will learn it. B will forget it again. So you can put a new color underneath and learn that with A. Oh, it picked an unexpected color. Forget it with B. A. There we go. Okay, how's everybody doing? Give me some thumbs up when you were able to train it to learn a color. I'll go ahead and forget this, and then
Can you explain that again, Andy? I have something, a color, and I'm pressing button A.
yeah,
Am I
so button
gonna,
A is on the microbit. It's right here.
right, no, I got that. So I just press it. I
Yeah,
get a
so well,
solid
what you
X.
want to do is you want to be watching the screen, and there's a bounding box that's on the screen. And when you put a distinct color in the middle of the crosshairs in the center of the screen, the size of that bounding box should envelop the color you've got. So right now I see the bounding box and it's right around the red cap of my screwdriver. So I can press the A button and then it will say color ID 1. Now, if we have any mistakes whatsoever up here, that might not work.
No, I got that. You were doing multiple colors. Will it save more than one color?
It will, but not with this script. This script is only designed to remember a color
Like it
and then
says,
forget it
right.
again. So you can forget it with B.
Okay, that's what it was. B forgets, one adds. I got it.
And then A remembers. For some reason, it's not really doing a good job with green today.
That might be a bit of a problem with agriculture in the future.
Just a little, you think? I think if we got it out in the sunlight, it would really, excuse the pun, shine on recognizing green. So, so what I would like you to do now, you can use computer. So right now, my computer screens are kind of busy and it would be hard to hold the camera so that I could hold, oh, wait, just use my phone. Okay, so I'm going to go to learn.parallax.com, down, back, new tab. Okay, so basically on my phone, I'm going to go to AI, machine learning, and vision with the Cyberbot and Python, and then go to the first lesson, and then continue. And then I think down at the, where are the, okay, so here we've got some colors. So let's see if, guess I'll need to move my lights away here. There we go. So if I increase the size of, I guess we'll try the blue here and tell it to remember that. Notice that it remembers, and then hit the B to forget, and then go over. Forget, remember, and there we are with green. And so what you'll be able to do is use your phone at the learn.parallax.com site to go through, and what you're going to be doing for homework is there are lots of fun things that we can do just to get the Husky lens moving. Now, I'm going to show you some things that we probably don't want to try with our current mounting. So the respond to objects coordinates, this one is designed to have the Husky lens mounted on the front of the bot for it to follow an object around. So I would say skip this one, but even the gatekeeper should work fine, showing it a face and having it, only let a person with a given face through to whatever resource they're trying to get to. So we're just going to have you go through. We just finished get started with the Husky lens, and you have all the scripts. I actually will have to put in, I believe, the gatekeeper script. I think that I may have given you an incomplete version of gatekeeper, so hold off on that one. But you'll have lots of good stuff to do with. I'll send it to you, or I'll let you know when this is up in the folder and ready for download. But the machine learning, train the Husky lens to recognize, and then remember data with micro SD. Both of these you can just totally go through on your own, and remember to use your phone, because if you use your phone, you'll have this script. You can just download it and run it, and then when you show it these colors in the phone. Now this page that I went to is the second tile, and this is where you're actually going to learn more than one color, and then you'll learn more than one face. And then we'll also, these QR code looking tags are actually called April tags, and you'll be able to train it to learn those too. And then we're going to have you train it with the micro SD card. So you'll essentially use the micro SD card that you've already inserted, and then you will run the script, and it has some step-by-step instructions on how to train it and how to store it to the SD card, and also how to retrieve it. And so we'll just have you go through those three probably, and I'm still on the fence about whether having you go all the way to gatekeeper. I will probably upload something so that you can try out gatekeeper, but that is still in progress. But this will definitely be some fun stuff to try out. And again, you don't even need to print these. You can just show it to the Husky lens with your phone and train it just looking at your phone. Or if you have a color printer, print these up, and then these will print just fine with the black and white printer, and you can do it that way too. You can even cut these out and leave a little extra underneath or above so you can hold on to it and present the April tag to the Husky lens. So that will be your homework for getting ready for next Monday, and then we'll try to put all this together. So you'll want to have your robot able to follow a path, able to park in the barn, and then we'll use the Husky lens to start recognizing plants along the roadside and have it do something to them. Okay.
Those tags, does the orientation matter?
I don't think it does.
Okay. I didn't think it did. I've seen them before, but I figured I'd ask.
Yeah. I don't know if I've actually put that to the test though. I'll have to, if I try that out and find out that that the orientation does matter. Again, I really don't think it does, because that is, the design of the tags is so that basically these two borders are going to allow the camera system to straighten it out if you're viewing it from an angle, and all manner of other features are built into this. So it should be recognizable in any orientation. But I will email if I find out otherwise.
I'll probably figure it out too.
Okay, well, drop us a line if you see that it's not the case. All right. So those pages that I showed you, I'll go ahead and send them. I'll send you links to the pages and that will have you do for homework. And again, I'll also make sure that the pre-written code is in this folder. And so that's all I've got for you today, which is just as well since we're 5 minutes over time.